This video is a short presentation of stress and strain. Now, to calculate the mechanical properties of materials, we have the minor or basic parameters such as stress, strain, and Young's modulus. Okay. For the stress, it is the ratio of force and area. The SI unit for stress is Pascal or Newton per meter squared. For strain, this is unitless and it is the ratio between the change in length and original length. Okay. For delta L, this is equal to the final length minus the original length LO. Now let's proceed with the Young's modulus. This is denoted by E. Okay. I repeat, E stands for Young's modulus. Young's modulus is the ratio between stress and strain. If we're going to expand this formula, this becomes force per unit area over the change in length per original length. Now we have the first example. A nylon string has a diameter of 2 millimeters pulled by a force of 100 newtons. Now we are going to determine the stress of the nylon string. We are given with the force exerted on the nylon string as 100 newtons, and the diameter of the nylon string is in 2 millimeters, or in meters, this is equal to 0.002 meters. Remember that 1 meter is equal to 1,000 millimeters. Now we have radius. Okay, this is just half of diameter. It is equal to 1 millimeter, or in meters, this is 0.001. We are required to determine the stress. Now, if we're going to proceed with the solution, first we need to solve for the cross-sectional area wherein the force was applied. Okay, the cross-sectional area for the nylon string is in terms of circle. Now, the area of a circle is equal to pi r squared. If we're going to plug in the values, this is equal to 3.14 for the two decimal places for the pi, multiplied with radius squared. So this is 0.001 meter quantity squared. This gives us this value, or in scientific terms or scientific notation terms, this is 3.14 times 10 raised to negative 6 meters squared. Now, our stress is equal to force per area. If we're going to plug in the values, this becomes 100 newtons all over 3.40 times 10 raised to negative 6 meters squared. Now we have this an answer as 31.5 times 10 raised to 6 Newton meter squared, or in Pascal. Or this is also equal to 3.15 times 10 raised to 7 Newton per meter squared, or Pascals. Now, the second example is a cord has original length of 100 centimeter is pulled by a force. The change in length of the cord is 2 millimeters. Now, we are required to determine the strain, so we have this given parameters as the original length LO of this cord at 100 centimeters. If we're going to convert it to meters, this is equal to 1 meter. Now remember, a meter is equal to 100 centimeters, the conversion factor. And then we have the change in length, delta L, as 2 millimeters, or this is 0.002 meters. Now the conversion factor is 1 meter is equal to 1,000 millimeters. Now we are required to determine the strain. If we're going to proceed with our solution, strain now is equal to the change in length, delta L, all over the original length, LO. Plugging in the values, this gives us 0.002 meters all over 1 meter, or 0.002.